if you go back to 2006, one of the biggest problems at the time was that a lot of the sensors you have today didn't exist, or they were very, very expensive. So DJI really, we sort of rode on the wave of the smartphones and how that became a necessity in today's life. A lot of the same sensors you have in your iPhone or your Samsung, accelerometers or all sorts of camera sensors, a lot of these parts are actually included in drones produced by DJI and a lot of other such hardware makers. And as such, we were able to create a reasonable price point for our product to be accepted by the mass market. Moving forward beyond that, our first off-the-shelf, ready-to-fly drone only came out in the year at the end of the year of 2012. So realistically, we haven't even been a consumer company for that long. Before then, it was perfecting every piece of the pie to get to that point of having a ready-to-fly drone. Everything from making the flight controllers efficient, from making sure that the IMUs worked, the GPS worked well, and eventually we got to the step in late 2012 when we came out with the first Phantom. Since then, we've gone way beyond consumer drones. We've made handheld stabilizers, we've made Ronin big rig systems for Hollywood-level shoots, and of course enterprise drones, which is what I'll be talking a little bit about today. Great, so that's just an overview of the company. Here I have a brief slide showcasing some of our more well-known products. So on the top left there is our newly released Spark drone, which came out this May. So I actually have a Spark over there that we can play with later after my presentation. The key point that I wanted to highlight here is that what DJI does consistently is that we like to leverage features and technologies that make sense and prove themselves in the market. So when we first started with the Phantom, we didn't actually have a camera. We didn't have a socket to add a camera, so we had a lot of people figuring it out themselves. After we saw that market was ready for a camera, we came in with a fixed camera. The next generation after that, it became stabilized. And one of the key things that defines all of our products is really the gimbal stabilization. So what that means is that at the front of the drone, if you see over there, the camera is not fixed. It's actually standing on a 3-axis mechanical gimbal. That's what allows us to produce those cinema-grade, smooth tracking shots that you see from Hollywood productions. And so, we decided, hey, so that can shoot really good video. Why don't we bring that to the earth, to the ground level? And so then we leveraged that exact same technology to create the Osmo Mobile, which is a handheld 3-axis stabilizer that works with any mobile phone in the world. That same technology is used in our Ronin 2, which can carry anything from a Canon or a Nikon basic level camera all the way up to your Reds that are used for Game of Thrones and Narcos and all these other high budget productions. So really my point here is that we build upon what's been market proven, and we really try to leverage past technologies to make future products as successful as possible. And then just for good measure, the bottom left there is our Mavic Platinum Pro product. It came out a month or two ago, and really I think the Mavic personally is my favorite product. It revolutionized the way that drones are defined in the filmmaking and photography industry. This bad boy over here packs a lot of punch, and it's only about the size of a water bottle when folded up. So as you can imagine, it was quite a groundbreaking move for the entire industry. Any questions so far? Okay, great. So a little bit more about the company. So we were founded, as I mentioned, in '06. The founding team was about 20-ish people. Since then, we've grown to about 11,000 people, including factory staff as well as all of our global offices. The point that I really want to draw here is oftentimes, as Tully mentioned, hardware is very, very difficult, and it's very expensive compared to what you can do in with software. And so one of our core competencies and what makes us stand out is that we leverage Shenzhen and we leverage the R&D talent that can be found here. So out of the 11,000 people or so, 25 to 27% of these guys and girls are R&D folks. I think if you compare us to other similar hardware companies, you'd be hard pressed to find that number of engineers working on software and hardware. Great. The next part I want to talk about, yes, please. Yeah, that's a good question. So actually, Frank, before he even left college, one of his master theses was to work on flight controllers and how, again, the building blocks to make sure that drones can become what they are today. So 2006 isn't the whole picture. If you go back a couple more years, his professor, his mentor, also a stakeholder in the company, had worked on this technology for quite some time. Yeah. Okay, great. So the real focus of our company from a 4 pillars perspective is that we really focus on the product, and we make sure the product itself is high performance. In addition to that, it's really about affordability. So drones before '06 could cost anywhere from $2,000 upwards to $20,000 for some simple mechanics and use cases. And so again, hijacking the wave of smartphone revolution and such, we were able to make drones not only affordable, but also high performance. The next part is flexible. We want to make sure that our products, even at the consumer level, can be used for things beyond just photo taking and video filmmaking. And then finally, we want our product to be accessible, to be available at any part of the world, and to anyone with the desire and the want to learn how to fly a drone. So together, these 4 pillars really define our product roadmaps, as well as what we end up developing in the future. A good example of this is actually our Spark drone, again, the one that I brought over. So here you actually see the woman using hand gesture mode to take a photo of her friends indoors. And so for us, the biggest action there was we wanted to hit the mass market with our Spark drone, and we wanted to make sure that people, millennials and other people that are more and more intertwined with social media were able to quickly get their hands on the best experiences with their friends and with their families. So to brief over the role of a drone at work, this is getting into more of the enterprise space. You hear a lot of Fortune 500 or really wealthy tech CEOs always talking about, well, data is the future, data is the new gold or oil. And at DJI we really do believe that. Nowadays, how can we make the world run more efficiently? It's about data crunching. It's about machine learning and big data, all these buzzwords that we're always hearing about. And a big part of that in our case is to come up with a platform that's suitable for its conditions, that platform that can hold a sensor or a payload, and then finally a flight planning software that can bring it all together. The next part is once you've got the data, with raw data, you really can't do much. So how can you process it in a way that it makes sense? We have 2 parts. The first part are our onboard computers that are available on all of our drone platforms. And then secondly is the analytics software that DJI provides in-house, but also the partner software that we develop in order to address customized problems in the industry. And then finally, we have the execution side. So primarily nowadays, what drones are mainly used for are collecting data and insights, and how can we use that with our existing workflows. For example, if you're a farmer, what you can do now is you can capture the field as a 3D model or as a 2D model, and then guide your existing crop dusters with the data that a drone has collected. However, the long-term goal is, of course, to have drones become the actual machines for execution. So I'll talk a little bit more about it later, but in the agriculture space specifically, the execution part will be DJI coming up with our own spraying drone to act upon those insights. Great. So before I jump deep into enterprise work and B2B stuff, are there any general questions about consumer space, the company's vision, or anything else I can help address? Okay, great. Moving on to the enterprise part. So I'll let the video do a bit of the talking since it does a good job of introducing what the industry is about.
Over the last 10 years, DJI has brought pro-level aerial photography to the masses. Explorers, vloggers, professional videographers, and photographers have all taken to DJI's intuitive, easy-to-use drones, camera stabilization systems, and more.
Innovation and creativity are at the heart of DJI's mission, and that philosophy has kept us at the forefront of the drone industry. As a result, we've grown to over 11,000 employees in 17 offices around the globe, with almost 1/4 of those staff dedicated to research and development.
At the same time, DJI is committed to developing unique drone solutions for leading businesses with DJI Enterprise, a team dedicated to forging drone solutions for a new generation of work. Labor trends show an abundant supply of critical thinking and analytics talent, and a worrying shortage of workers willing to perform dangerous, often dirty and difficult jobs, a combination that puts pressure on many companies in many industries. DJI Enterprise seeks to address these issues by reinventing the way business is done through advanced aerial technology.
The drone solutions that we've developed here at DJI Enterprise are designed to empower businesses by improving efficiency and safety for tasks in the field. We are opening up new data streams for industries to act on real-time information. The core of a drone solution is an aerial robotic tool that allows people to complete more work in less time. To build on the functionality of our platforms, DJI has developed compatible payloads, including cameras, sensors, and even emergency supply drop boxes. Our payloads give enterprises new and improved ways of seeing and interacting with their operations, revealing methods to better manage projects and complete them on time.
In addition to DJI's hardware, DJI has developed an ecosystem of internally and externally developed software on top of DJI's SDK. The software available includes anything from automated flight apps to image stitching and asset management platforms.
DJI, together with our developer partners, can offer clients drone solutions that integrate drone platforms, powerful payloads, and software solutions to bring industry leaders into a new realm of drone-based work solutions.
Ultimately, with DJI Enterprise, we want to make businesses smarter, leaner, and more efficient. There are now fully realized solutions for agriculture, infrastructure, construction, media, energy, and public safety. It goes without saying that our push into commercial drones is a part of a search to find a better way to apply world-class aerial technology to all of these sectors and more.
Cool. So that video just gives you guys an overview of some of the key industries that we've been focusing our efforts on. And you'll also notice that those key industries, most of them are mired in traditional workflows, even sometimes pen and paper. And so it produces a very good market opportunity for us to come and disrupt what's currently available. So one of the things that's allowed us to do that is actually policy. So when we think of technology in the consumer space, we don't really think of policy as much. But in the enterprise space, especially dealing with new UAVs, that's one of the key obstacles that not just DJI, but other players in the space constantly face. And so up until about mid of 2016, you would need an actual pilot's license to fly a drone commercially. And so as you can imagine, that's a huge barrier to entry for anyone who's hoping to, spray their crops or keep track of their site mapping and such. But thankfully, come August 2016, that was revoked, and a new Part 107 certification process was introduced in the US. So since August of last year till about September of this year, the FAA reported about 60,000 registered commercial pilots in the US. Again, these are pilots who are doing commercial work with UAVs. About 43,000 of these people are flying DJI rigs, a combination of both consumer products as well as the industrial ones that you see as well. So again, going back to what really makes a drone solution possible, there are many parts. And when you think about big companies like your BPs and your Shells, what they don't want is to have to learn everything from scratch. How do you actually build a drone? How do you fly a drone? What is the insurance policy? How do I get people trained? And so what we're really seeing is that large B2B partners of ours are looking for solutions that encompass all of their needs. It just needs to work. And so a big part of that is, again, choosing the right platform. And a lot of times our partners make that decision for big parties. On the top, you have industrial platforms that are first more rugged and made for industrial environments. But then secondly, they're much more customizable for unique solutions. You can hook up a LiDAR unit or an RGB camera as you see fit. On the bottom, we also see a lot of our more enterprising and our more creative customers actually using our consumer products to do most of their work. What they do, they either buy it off the shelf with no modifications whatsoever, or they make minor modifications for their specific workflows. The second part is, of course, the payloads. Payloads can range from simple cameras to thermal infrared cameras, all the way to third-party payloads that serve completely different functionalities. For example, we saw in the video earlier that one of our internal teams developed a supply drop box that you can hook up to industrial drone. And in the cases of search and response, when every single second and minute counts, medical supplies and food or water can make the difference when it comes to saving people's lives. And then finally, we need the software to bring everything together. So on the DJI end, we've developed, again, 2 example software solutions to address those needs. The first one is DJI Pilot, which actually helps you guide industrial drones. And the second one is the ground station, which helps with mission planning and flight planning. And then finally, we do have a software development kit that's available for many of our consultants and partners in the space. Many times, the ready-to-fly off-the-shelf drones aren't equipped to deal with their specific needs. And so the SDK enables and really gives the power to our partners to develop their own functionalities as they see fit. So this is a brief overview of what we consider some of our industrial rigs. For those of you guys who are familiar with DJI products, I'm sure you guys don't think too much about these particular machines. On the top left, we have the Matrice 200 drone. What makes it unique is that it's very scalable, it's water resistant, and it's also dust proof. It allows up to 2 cameras to be attached on the bottom, in addition to the first-person view camera that's on top. So you can imagine the wide variety of options now that you can do with regards to industry inspection and action. The Matrice 100-600 on the side here look a little bit bare-boned, and that's because they're built specifically to be customized by third parties. A lot of our core partners in the space, whether they're working in construction or public safety, have actually purchased these drones from us primarily to start attaching their own payloads or having their own branding or having more protection built in. Again, very versatile depending on your industry needs. And then finally on the bottom, the Wind 4 and the 8. These 2 bad boys were released actually just last month in the US. And the Wind 4 is primarily a heavy lifter. This one can lift up to 13.5 kilograms, which is quite high for the industry standard. And then Wind 8 is known for its redundancy features. With 8 different rotors, if one were to happen to come off for whatever reason, you're able to quickly land the drone in a safe environment. These are basic specs, so I won't go too much in detail. If you have any questions about these, just find me afterwards. And like I mentioned earlier, some of the more enterprising of our customers prefer to take off-the-shelf options. Spark, Mavic Pro, and P4 are all drones that we sell at Best Buy, and people can just buy for their own personal use. But a lot of these cameras are good enough for basic inspection, as well as good training for large enterprises with in-house teams before they upgrade to the enterprise versions. And then, of course, the Inspire 2, our professional filmmaking drone that's used on the sets for Game of Thrones and a lot of other big budget productions. Again, more specs. Great, so deep diving into specific solutions, running through with you guys some of the verticals that we really identify. So I know on the board there are 6, but really we consider the first 5 our key industries in the coming few years. Public safety, construction, infrastructure, energy, and agriculture, these are all individually trillion-dollar industries globally. As you can imagine, are all very archaic in the way they operate currently, and drones can provide them with a different perspective and a different way of capturing data. Media, we sort of consider a 5+1 because we do have an internal team focused on just developing filmmaking solutions. Great, so on the topic of infrastructure, what we consider infrastructure ranges from railroads to bridges to transportation networks. I want to deep dive specifically on bridge inspections because just to run you through what it takes currently to do a bridge inspection is quite mind-blowing. So say, for example, you're an engineering firm and you're tasked with making sure and maintaining that the bridge won't collapse in the next year or so. What you would first have to do is divert oncoming traffic and block off the bridge for many hours at a time. That's already an initial risk, it's a cost, and it's very inefficient. Once you divert traffic away from the bridge, you would then need to construct a temporary scaffolding right under the bridge. Otherwise, you can't send people up to actually visually inspect the platform. Once you build the scaffolding, you would then have to send an engineer or technician to go up, inspect to the steel truss, and inspect areas that are of high risk before you can complete your project. That whole process is costly, it's risky, and it's also very, very time-consuming. Now what we can do with a drone is instead of having people go up there, you have a piloting engineering team flying here, bring a drone under, have an upward camera that's able to zoom up to 30 times, and you can see all the minor damages or cracks that may be happening in your bridge for a quarter or a fraction of the time, the cost, and of course the risk. So you can already see these solutions are available in the market today, and that's what we're helping do for a lot of these construction and asset infrastructure firms. Mining, telecom, again, similar use cases all across infrastructure. Agriculture is a big one. So we all know that, agriculture is a $1 trillion industry around the world, anywhere from developing economies, spraying by hand, all the way to developed economies using, big crop dusters and tractors to manage their farms. One of the really cool things we're able to do today is what is known as precision agriculture. So say, for example, you're a farmer in Kansas, and you want to know more about the land or the crops that you're growing. So traditionally, you would have to walk around to capture images to stitch them together, or you would have to rent or buy maps from a satellite. With satellites, sometimes there are clouds over your farm, sometimes they're just not clear enough. What drones allow you to do at a low cost is to actually just buy a drone, use the flight planning, mapping, and stitching software, and come up with a 2D or 3D map of your very own farm as it looks today. And again, that process can be repeated every day if you want, every week if you want, or every month, depending on your need for frequency. What's really cool is that once you have that 2D or 3D map, you're then able to run very in-depth analysis to see exactly where your plants are not as tall as they should be or are not as green as they should be. In fact, it's so precise that you can see the levels of photosynthesis based on just a map you get from a drone. Now, what's really cool and what that allows you to do is then you can build flight maps based off your 3D map or your 2D map that can then be actioned by a spraying drone. The spraying drone would know exactly where to put the fertilizer, the pesticide, and water or any other substance you may want to spray. The traditional method, as you guys may know, is really just hiring a big Cessna plane, loading it up with fertilizer and water and pesticides, and just spraying it all over your farm. Because up until now, we really didn't have the insight to do precision agriculture. Needless to say, you save so much money on your raw materials, you save so much for the environment, but most importantly, you save time, and you know exactly what's happening on a day-to-day basis for your farm. It's even more important for developing economies. Actually, one of our first test markets for the spraying drone was in China back in 2015. And in the more rural and remote parts of China, spraying for fertilizer and pesticides is still done by hand. And you and I both know that pesticides aren't exactly great for the lungs. So for developing economies, the added benefit is that you're also saving the health and lives sometimes of the workers on your farm. Any questions so far? So energy is a really, really broad term for us because it encompasses anything from power lines to renewable energy sources like solar and wind turbines, all the way to traditional ones like oil and gas and thermal generation plants. This is sort of like infrastructure assets as well, but what makes it interesting is that in the case of solar, for example, when you have a big solar farm that's 10 kilometers squared out in the middle of Nevada, steeping in the sun, the biggest issue is that you never know when your solar panels are not operating at full capacity. Each of these individual solar cells need to be inspected on a regular basis, and currently the method is just way too slow. So what you're able to do is to actually hook up a thermal camera that's able to see heat signatures onto a drone, do a quick map that maybe takes you 20 minutes, and then you're able to pinpoint exactly see where the cells that aren't operating at full efficiency are colder than the ones that are operating at full efficiency. Obviously, that insight gives you the efficiency to come into the field and make precision adjustments and fixes. So again, we see the same pattern over and over again in a variety of different industries that can save money and save time. The coolest thing is actually, just last month in November, we had an event in Denver, and we released the project Aeolus, which is what we called for the wind turbine inspection. So working with one of our partners out in the US, we were able to develop a autonomous solution, click of a button solution essentially, that allows you to not only 3D map the wind turbine structure, but also to automatically look for any faults, any rusts, any places that need maintenance. So the reason why it's so significant is because once you have one proof of concept of inspecting a vertical structure, you can then copy and paste that into cell towers or other power lines or anything else that, again, would be a vertical structure. So traditional methods, again, involve powering down the wind turbine, sending someone to climb up the stem of the wind turbine, and inspecting everything by hand. The other way is to use binoculars from afar, which, again, is not very accurate for any measure. What having a drone allows you to do is not only are you able to see with millimeter precision the faults and the rust and the damage, but you're also able to actually keep a 3D map and then revisit it later when you're offsite. Again, that goes way beyond the capabilities of the human eye and saves time and saves the risk of people falling off and hurting themselves. So what we were able to develop with that solution was actually for the engineer. Again, a lot of these site engineers they're not pilots. They don't know how to fly an enterprise drone. What we were able to do is to create a solution where they literally come out on a pickup truck, roll out the drone, attach the batteries, power it on. At the click of a button, they're able to identify the wind turbine structure and do a cyclical loop around it, capturing all the photos it needs to stitch together at a later time. So that saves not only the cost and training and insurance of getting that pilot up and running, but also saves an incredible amount of money for the company. Oil and gas, power lines, nuclear, all fall under the same inspection category. Oil and gas, these flare stacks that you see constantly are burning to make sure that excess fuel don't get caught or don't explode while the plant is in operation. That again, the downtime is incredible. Like you would have to turn off the plant, wait for it to cool down, and then send someone up to actually make sure that the flare stack is okay. Now you don't even have to cool down. You can straight away get a drone to fly around the oil and gas oil rig, and using a thermal camera, see exactly where the cracks are and exactly what needs to be fixed to make this happen. Nuclear is a more interesting issue, actually. It involves a lot of internal GPS-denied environments, and so we're actually working with a partner in the space to develop an internal drone solution that can hit walls without damaging the actual function of the drone. Great. Construction front, again, construction is one of those big industries that's booming almost all the time around the world, especially in China. One of the biggest problems with construction is that I think the statistic is something like 17% of all construction projects either cost overrun or they get delayed. And that's pretty crazy if you think about it. And the biggest issue is that these commercial towers, as they're getting built, they're oftentimes not built as what the architect had imagined or what the 3D model actually looks like. So technology, in addition to drones, LiDAR systems and ground placement systems that can map the internal structure of the building, these technology advances that have come around in the last couple of years have really changed the game for these construction companies. Again, these behemoths that have billions of dollars wasted on delayed projects and having to redo things because the window was 1 meter to the left instead of being 1 meter to the right. All these issues can be solved if you have a day-to-day update of how your construction site is looking. I wish I could show you a GIF or something like that, but being able to do a loop around the building as it's going up level by level can save a lot of headaches and problems down the line. I did mention earlier that a lot of our customers are very enterprising and they're very creative in their use cases. Many of our insurance partners in the US actually use our consumer products to do their insurance claims as well as their rooftop inspections. So partnering up with a couple of machine learning companies out there, what's happening now is when you have a hailstorm and hail, big pieces of ice chunks hit your roof and damage your tiles, what used to happen is you have to send someone up there, look visibly with their naked eye to find damage and then report that in a paper-based insurance claim. Now what you can do is you can fly a drone literally 20 meters up, take a photo, and with machine learning algorithms, you're then able to use a computer to pinpoint where the damage is done and have a percentage of damage report which helps you file insurance much, much quicker and much, much easier. And this particular use case was actually highlighted in the recent disasters out in the US, especially with the flooding happening in Florida and Texas. Traditionally, we would have to send people up on the ladder. UAV technology is really redefining what it means to for all these different industries, but primarily to save lives and to catch criminals. Also, thermal technology and the darkness of night. If you have an escaped, if you have an escaped convict, he or she is very easy to spot in the middle of the dark. Great. And then, like I talked about before, media is one of our other industries that we have teams working on. It's more close to consumer products, and so a lot of it's being used in cinematography, on big budget Hollywood sets, all the way to location scouting and even wedding photography is what we're seeing. And so I won't cover that in too much detail, but if you have any, if you're curious, if you have any questions, please come find me afterwards. Yeah, and then I just wanted to leave you guys with this final graphic, because what really defines our work in the enterprise space right now, and even our consumer space, is our ability to work with partners in the industry. We started off as hardware developers, but you can never succeed and get to scale if you only work with yourself. And so if it weren't for our system integrators, our end users, even policymakers, we would never get to the place we're at today as a company. And so again, it's always about not only nurturing, developing the ecosystem, but working together with partners that make it all happen. Cool. Thank you very much for your time.